Our paper is working on two legs, learning image segmentation with noise labels. All the authors come from Fudan University, Jianpei Tech Company, and Zhejiang University, and Shani Technology Company. This topic is about image segmentation. Image segmentation is separate the objects and the background pixels in a given image. It is an active area of research in computer vision. In our approach, we propose a game-based approach, also combining with semi-supervised learning to use a small number of annotated samples to perform error correction and image segmentation simultaneously. And we use a recurrent network to explore the relation between these two tasks. In our approach, the relation is not modeled at for only one time, but this relation are explored in each skill of the feature maps, and it is explored for many times. The third one is that we use a discriminator. In this discriminator, the weight of the revised sample is adjusted according to the competence, and the weighted cross entropy cost function is used to fine-tune the segmentation network. This is the framework we use. We find that there are two units in this figure, which we call dual inference network. This network is used for the image segmentation and sample correction. And these two networks are combined by using our recurrent network, which is purple in this figure. And all these modules we use it as the generator in the game. And after that, we find out the result from the image segmentation network are the inferred mask. This mask is used for the segmentation loss, which is the binary, which we use the piecewise cross entropy loss, and the output of the sample correction network is the revised mask. This mask is used for the discriminator. In the discriminator, it is used to distinguish whether the input is a reasonable mask or the unreliable mask. Also, the original image data is also input, so the discriminator can combine the revised mask and the original input image to judge whether it is correct or not. These methods are used in a semi-supervised way. First, all the correct label data is used to learn a segmentation network. And then we can use all the correct label data and noise label data to fine-tune the whole integrated network. When the whole network is fine-tuned, only the image segmentation network is used for inference. In the test stage, new data use correction network and the discriminator network to learn the segmentation. And the relation between the image segmentation and the sample correction is implemented by the recurrent network. We have a function. In the function, the HK is the current layer latent vector, which is in the K layer or K scale. And WFK is the current network, is the current layer network weighter. Also, WIMD is also a network weighter to be learned. HK minus 1 is the preceding layer latent vector, and FK is a visual feature from the current layer. So when use this method, the visual feature and the mask feature from different layers can be combined and get a semantic feature. The last function we used is listed in this page. We use the binary cross entropy to learn the image segmentation network and the sample collection network, and we use the adversarial loss to learn the discriminator. And in the fine-tune stage, we use the L total to optimize the network. And after that, the weighted sample are used in the weighted binary cross entropy to learn the image segmentation network again. The experiments we used is Pascal VOC 2012 and the Shining Dental dataset. The Pascal VOC 2012 dataset has a lot of the images, both indoors or outdoors. And the Shining Dental dataset contains about 7,800 images. All of the images are collected and scanned from the oral environment. And the metrics we used in this experiment is class-wise IOU. It is the class of the ground truth mask and the predict mask divided by the union of both of the mask. First, we evaluate how many skills should be used in this approach to find the best skills numbers in the backbone. We find that 4 skills is reasonable and get best performance. So in the later experiments, we use a skill of 4 as to be all the skills in the backbone. And we also test. We use Great Searcher to test the different number of the factor lambda. We try different number and get the best number to be the lambda we used in the experiments. Then we train and test the results in both Pascal VOC 2012 and Chinese Dental datasets. In this figure, we illustrate the input, the results from the eigen and our approach. And the bottom line is the ground truth. Then we make a quantitative analysis of this approach. We find that though our approach is not as good as the state-of-the-art approach in the image segmentation, but our approach try to handle with the problem that some of the annotation data may have noise. So when the noise is incorporated in the data, in the training data and test data, we find that our approach can get the best results in this situation. That's all. Thank you.